Hello, my name is Shaun Wallace, and I will present a collaboration between Brown University, Adobe, and University of Central Florida.
See that? It's an aardvark. It's a mammal.
Input. Aardvark. Abyssinia. Adam Duck.
Holy crow, you can read!
Input. More input.
Okay, no problem. Volume 2, no problem.
More input, Stephanie. More.
Towards answering the question of how we may be able to accelerate adult readers, here we study the impacts of font on reading effectiveness. We want to study if personalized reading experiences can augment reading behavior in individuals. Could users' preference predict their effectiveness in terms of reading speed and comprehension? Could we develop a test for users that gives them their most preferred font and a definitive ranking of all of their font choices? Bylinskii's past work served as the basis for several similar studies over the past 20 years. These studies compared font type, size, preference, reading speed, and reading comprehension. Rainer's impressive work spans the 1970s to 2012, summarized in The Psychology of Reading. Wallace shows findings made by previous work have become less relevant, due to changes in the diversity of available fonts and the devices we view them on. Psychophysical work done at MIT leverages staircasing to normalize a lexical decision task to show thresholds directly relevant to real-world tasks in glanceable reading at infotainment. Our digital reading experiences have undergone rapid change in recent years, with variable fonts creating text that can change dynamically. In the future, we hope users gain the control to individuate their reading experience. Adults often read in short, opportunistic interludes. This interlude reading lies somewhere between the well-studied glanceable and long-form reading. Interlude reading happens in a single brief sitting. We use Carver's recommended range of 138 to 600 words per minute to remove those who are skimming or reading for memorization. We studied 16 fonts in total in our study, covering fonts popular in PDF, newsprint, and the web. We also included 4 fonts recommended by readability experts. In 2016, Relo clearly shows us that size needs to be controlled. We found in preliminary studies when all fonts were the same size, that size predicts preference. For example, many fonts are designed to have a larger height for a lowercase x than others. This is a lowercase x in Times, where this is in Montserrat. When these are overlaid, the lowercase x in Montserrat is clearly larger. In our work, we decreased the size of Montserrat so it has the same x height as Times. We ran a study with 61 participants to determine how humans perceive font size. Taking Times at 16 pixels as our reference font, we computed 3 new font sizes for each font in our set, corresponding to matching the reference in each of x height, or width. Normalizing by width or height corresponds to adjusting the font size of the target font until its width or height of a set of characters matches the width of the same characters rendered in the reference font Times. Our interface presented participants with the same piece of text rendered in 2 different fonts side by side. One screen always contains the reference font Times, while the other screen contains the target font. Participants toggle between 4 possible settings for the target font: the font at size 16, and then the font normalized by x height, or width. After toggling through all the settings, a participant would click to select the setting most similar in size to the reference. The figure shows how each font size was adjusted based on results. Only 3 fonts, Oswald, Franklin Gothic, and Calibri, were perceptually the same size as Times. Garamond was the only font that increased in size, whereas Montserrat was decreased in size the most. In this work, we are interested not only in what is your most preferred font to read in, but also what is your most effective font to read in. If we want to determine font preference, what is the best way to do it? In the past, Bylinskii arranged 2 physical monitors side by side for users to make pairwise comparisons between different font types. We developed a web-based toggle test that should feel familiar to anyone who has ever done an eye exam. Participants perform these comparisons in a double elimination tournament that produces a winner or most preferred font. Also, this allows for the creation of a definitive font ranking across all 16 fonts per participant using ELO ratings. ELO ratings can be used to account for strength of matchup for each pairwise comparison. We use this basic interface that is fixed across all devices, that allows users to toggle between a single paragraph and two different font families. After users have seen each font, they can select which one they prefer. To study font preference and effectiveness, we used Amazon Mechanical Turk to run an order of magnitude more participants than past studies. We developed open source reading passages and comprehension questions for this study. Crowd workers who reported not being comfortable reading in English under the influence of substances or reported having a neurological disorder were removed from the analysis. All 16 fonts were used in each preference test. Participants read 5 total fonts for the effectiveness test. We removed individual measurements of reading speed below 100 words per minute or above 650 words per minute per Carver's recommendations. We used the interquartile range method to remove outliers for comprehension scores. In our work, reading speed is correlated with font choice and not participants' familiarity or interest in a reading passage, nor their familiarity with a particular font. Also, reading comprehension scores remained consistent. We found that speed is correlated with font, indicating large individual differences. The following visualization shows how average ELO rating per font changes after each participant completed their preference test. ELO rating systems aims to minimize the differences between expected and actual outcomes of competitions, or in our case, pairwise comparisons. Bars per font are highlighted in green or red if they're in the top 5 or bottom 5 in average ELO at the end of the study. Some fonts stabilize faster in the rankings than others. We found overall it took hundreds of participants for the preference rankings to stabilize. Prior studies only covered 20 to around 100 participants. Overall, Noto-Sans was preferred by a majority of participants based on these metrics. The following is an example of ELO ratings per font changed during one participant's preference test. This participant preferred Noto-Sans the most overall, while they did not prefer Garamond. Across the entire study, Times and Garamond were also highly rated fonts. However, they led to split opinions across participants, some of which consistently voted them up and others down in the preference tests. In contrast, Open Sans and Arial were consistently likable, even if they were not voted as most preferred by as many participants. In a post-survey, participants described their most preferred font as bold and modern with natural character spacing. While many older participants wanted a font that decreased eye strain, younger participants preferred fonts with tighter character spacing, believing this would help them read faster. The following visualization features a range of reading speeds for each of the 386 participants, sorted from slowest to fastest. Notably, faster readers tended to have greater standard deviations in their reading speeds. Participants only read the fastest in their most preferred font 20% of the time. Given they read in 5 total fonts, this happened at random. However, reading in their most preferred font did not hurt them either. Overall, preference did not negatively or positively affect reading speed across participants, regardless of their reading ability. We found that font preference did not predict effectiveness. Despite 73% of our participants believing their most preferred font would be their most effective font to read in, this only happened at random. In general, people did not read faster or slower in their most preferred font. An additional finding is that 92% of the participants believed the final font recommendation given to them at the end of the double elimination tournament. In our study, every participant read Noto-Sans, because it was consistently the most preferred font in our pilot studies. Our results show participants only read the fastest or slowest in Noto-Sans at random. This shows that Noto-Sans can provide users with a potentially enjoyable reading experience while not helping or hurting their reading speed. In addition, every participant read in Times because it is one of the most ubiquitous fonts across all mediums. Similar to Noto-Sans and participants' most preferred fonts, Times only positively or negatively impacted participants' reading speed at random, which means it is still safe to read papers in Times if you want to. Overall, we found there is no single font that would increase reading speed on average. However, individual participants did experience the benefits of reading faster in a particular font. Our average reader read at 275 words per minute, indicated by the red line on the visualization to the left. Each row is a participant, and each dot is the average reading speed for a font. Reading speeds in Noto-Sans are in gold, while Times are in teal. The reading speeds for the most preferred font are black dots. Participants in our top quartile for the delta between best and worst font added 93 words per minute, or 8 pages per hour. Our average reader could add 38 words a minute by merely adjusting their font. This is equivalent to an additional 3 to 4 pages an hour. Across all participants, average comprehension remained similar and high. Even the slowest of readers in our study experienced performance gains. showing that readers of all ability levels can read faster with the right font. In the context of interlude reading, this gain is perhaps best framed in the ability to consume more in limited windows. We found that running large crowdsourced reading studies should not rely on traditional metrics of averages. For example, on average, Garamond had the highest words per minute, while Open Sans had the lowest. However, SpeedRank shows that Garamond was only faster than another font for a participant 48% of the time. In contrast, Open Sans was faster 54% of the time. This indicates SpeedRank can help uncover strong individual differences, and that perhaps Open Sans was the most beneficial font to show to slow readers. A mixed effect repeated measures model shows significant differences in measured reading speed per font, suggesting that certain fonts have consistent performance benefits or decrements within participants. For instance, accounting for average reading speed, some participants achieve statistically significant gains when reading in Noto Sans or others in Times, for example. In our future work, we plan to investigate which factors are predictive of a participant's optimal font. Our gains and findings show different fonts are effective for different readers, of all performance levels. This observation points to a future where machines can help adult readers reach their full potential by merely changing a font. Thank you for watching our pre-recorded talk. If you would like to take the tests featured in this study, please visit readabilitytest.org. And thank you to all of the groups who helped collaborate on this work. If you have any additional questions, feel free to email me at shaunwallace@brown.edu.
I'm Dr. Bendy Sawyer, Director of the Virtual Readability Laboratory at the University of Central Florida. Interested in what we're doing here? Find your own best format with the same tests at readabilitylab.xyz. Or join us. We're looking for collaborators and have positions for PhD students starting this fall, as well as postdocs and staff. Take a look online and reach out.